Hi, I'm Rahul Chavan. I'll be presenting the project Emotion Recognition using Python and OpenCV. This is a project as a part of coursework Pattern Recognition taught by Professor Dr. Dapengwu at the University of Florida. So, what is emotion recognition? Emotion recognition is extracting the emotions out of a facial image of a person. Emotion recognition is currently one of the most trending topics in the industry. This emotion recognition enhances human computer interaction. Just imagine human computer interaction will be more natural and interesting if computers are programmed with the intelligence to identify and respond to human nonverbal communication forms like emotions. This is an active research topic, the field of computer vision. Facial expressions give an important clue about a person's emotions. This field is a boon for the medical industry, entertainment industries, and many other industries to rise. Currently, there are three methods to identify emotions out of images. The methods are eigenface algorithm, Fisher face algorithm, local binary patterns histogram. Out of these three methods, we will be using the Fisher face algorithm for our project. This is because Fisher face method has error rates lower than the eigenface method, and it requires less computation time. All of these algorithms perform perfectly when the lighting is proper. However, as lighting is moved off the axis, results indicate that Fisher-Face algorithm performs better than the rest. So, we'll be proceeding with the Fisher-Face algorithm. Before explaining the details of the Fisher-Face algorithm, I would like to start with the demonstration of the project as the initial steps take quite a lot of time to execute. So, the first step will be segregating the images based on the data types, based on the emotion types. As we can see initially, the folders I have created separate folders for each emotion type. So the first step will be to organizing the data set which we have. We are using the Con Canada database for this project. So first will be let's organize the database. This script will organize the dataset into the different folders which I had made separately for each emotion. Once we have organized the dataset, the next step is to extract only the facial part of these images. So we'll be running the script extracting face.py. This has started extracting the faces from these images. As we can see from the code, we are using cv2.cascade classify. This is a HAR filter provided by OpenCV for extracting the faces from the images. We are using 4 classifiers for this. These are the 4 classifiers which I had downloaded from the OpenCV website. So this classifier will segregate the facial part and will just save the cropped facial part of the image in the dataset. This will take quite a lot of time, so we'll proceed with the Fisher face algorithm. So the first step in Fisher face algorithm is to construct an image matrix. So first we'll be constructing an image matrix X where each column of this matrix represents an image. Each of this image is assigned a class in its corresponding class vector, say C. Next step is to project this image matrix into the NC dimensional subspace as P, where the rotation matrix WPCA is identified by the principal component analysis method. Next step is to calculate the between classes and within classes. For calculating between class scatter of the projection P, we'll be using this formula mentioned in the slide. Here, mean is the total mean of projection matrix projection P. Mean of I is the mean of class I in P, N of I is the number of samples of class I. Next step is to calculate the within class scatter of P. This is given by this formula. Here the xi is the sample of class I, xk is the sample of xi, and mean of I is the mean of class I in P as from the previous step. So after this step, the next step is to apply the LDA method. Yeah, LDA stands for linear discriminant analysis. What LDA will do is that LDA will maximize the ratio of the determinant of between class scatter obtained in step 3 and the within class scatter obtained in step 4. So after this stage, the final step is to obtain the Fisher phases. This is given by the given formula, where WPC is the rotation matrix which we obtained from the step 2 after the projecting the matrix in the NC subspace, and WFID FLD is the generalized eigenvector which obtained from the previous step, that is the linear discriminant analysis method. So the methodology to test this project is that first we need to organize the dataset, which I showed you a couple of slides back. So we have made separate folders for each emotion type, extracted the images in the source folder. Each image, so this the database which we are using is the Con Canada database. In this database, we are provided with different image sequences, where each image sequence starts with a neutral phase image, followed by the images depicting various emotions. So our task in this stage is to separate a neutral phase image and its corresponding emotion image from this image sequence. So we are done with the step 2. Second is to extract the faces. So we'll be using HAR filter provided by OpenCV to extract from the image. After we have extracted, we'll crop the image and save it in the database. As we can see here, only the facial part of the image has been cropped and saved. So we'll check if the second step has been done or not. It's still in progress. So in the meanwhile, I will discuss the steps to follow. After we are done with the second step, the next step will be to create the training and the classification set. Since we have a limited data set of about 506 images and its corresponding emotions, so we'll be splitting this data set into two sections. Let's assume that 20% will go to the training set, and the 80% which will be using to identify the emotions by training the data set of 20%, and will identify the 80% of the data. The final step will be to test and analyze the results. So next step is demonstration. We already started with the demonstration. We'll wait till the this script keeps on running, stops running, sorry. So what this script is doing is that we can check in the dataset folder. Initially when I showed this were empty. As we can see, the images are getting populated in this folder, and only the facial part has been populated. So as we can see, there are many images depicting anger. Similarly, we have for this data set. In the meanwhile, so we are done with the extracting the faces part. The next step is to train our algorithm so that it can accurately identify the different emotions of an image. So this is the script which we will be using. So we'll be using the Fisher face class provided by OpenCV, which will recognize the face part of the images. So we are defining two functions. So this loop will be training the algorithm, while this loop will be predicting the algorithm. So since this will take quite a lot of time, I have reduced the training set data and the prediction set data. We'll be using around 250 images for this test, so that it can be so that I can show this demo in limited time which we have. So I will start with the training and classification part. So as we can see, the total data set now consists of 224 images. We have more than 500 images, but to restrict the time, restrict the demonstration in the time which we have, I have limited the image count. As we can see, for the first emotion type, we have got 84% of the data, emotion recognition data, which is correct. 92% for the second type. As we can see, the the count for different, the accuracy for different emotions is differs drastically. As we can see, for the first type we got 84% accuracy, whereas for the second we got 92% accuracy. This shows that the algorithm is not even in identifying different emotions. It also depends on the number of sample images which we have for a particular emotion. Also, some of the emotions are quite easy to identify, whereas some of the emotions mix up with other type, so the algorithm might get confused between the two of them. I will be sharing the examples in the next slides for this. Currently the accuracy seems to be around 85 to 87%, but this accuracy can be increased if we increase the data set size. So we are quite close of finishing with this algorithm. At the end, this algorithm will calculate the total accuracy of this average accuracy of this system. So I'm hoping it will be around slightly greater than 85%. It's about to finish. So the accuracy, the end score is about 89.54%. So roughly 90% accuracy we have achieved using this method. So the next step is to analyze the results. So uh, I have I have analyzed the results and drawn a graph to depict these results. This was for a larger sample space. So as we can see, the results are different for different emotions, and the results seem to be highest for the emotion happy, and seem to be lowest for fear. So this will also depend upon how many sample spaces we have for uh, each each emotion type. In the code, we have selected the limited images which I have selected were selected randomly. So there should be some error in our algorithm, which because of which we are not able to detect the correctly. This is not actually an error, but some fallacies in the results are due to these results. Say, as we can see in this image, this seems to be a surprising face as well as an happy face, but our algorithm has classified this image as happy image, but it's actually a surprising image. As we can, the next example shows the image as the person is discussed, but it looks similar to a sad face, so our algorithm has classified this as sad. Similarly, for these two images, the first image, it clearly indicates that the boy is crying, but the algorithm failed to identify this and has classified this as disgust instead of sad. The next step is, as we can see, the algorithm has classified it as happy, but the actual expression is anger. This might be because of because below pattern indicates that the person might be smiling. It didn't take into account the anger part in this image. So finally, I would like to conclude that if all the seven emotions, there are seven different emotions like happy, sad, fear, contempt, disgust, etc. Out of which, if all the seven emotions are tested, then the accuracy is about 85%. This is for a large data set. As we can see, for a smaller data set, the accuracy was 89.4%. This was because I guess randomly it selected the images for which it was able to exactly find out the emotion. This accuracy can further improve by increasing the dataset, as I had said earlier. Also, the results indicate that it is difficult to identify an emotion accurately by just using an image, because we cannot easily predict the emotion just by looking at the image of a person. We are not aware of the context behind which the image has been taken or elsewhere. So, however, we hope to solve this problem in future accurately by different algorithms as current research proceeds in this field. Thank you for watching my demonstration. Thank you.